Okay, I wanted to go over a few problems from the final exam review. So you probably noticed your final exam review is just your exam number 1, exam number 2, and exam number 3 review all put together. And I just include the key from exam number 1 and 2, and then the solutions from exam number 3. So I want to take a little bit of time and go over some of the more commonly missed problems on those exams. At the point that I'm making this video, you haven't taken exam number 3 yet, so I'm going through the problems that I think that will be most likely to be missed on exam number 3. Okay, so the first problem I want to go over on the review, on the final exam review, is let's go over the Venn diagram stuff. So starting off with number 2, it gives you the universal set, and it has the letters U, N, I, B, E, R, S, A, L. So this is all the letters that are options to use. Set A is the set of letters that is S, A, V, E. Set B is the set of letters that is R, U, I, N, S. And notice that this is a subset of the universal, and this is the subset of the universal. So part A asks for you to do A union B. So A union B means everything in set A along with everything in set B. Okay, so everything in set A would be S, A, V, E, and then everything in set B would be R, U, I, N, and then S, but I already have S here, so I don't need to write it again. So that's A union B. For part B, it asks for A intersect B. Well, A intersects B is something that is in both sets. Okay, so what is in both sets? Excuse me. So the only letter that's in set A and set B is the letter S. So the intersection would just be the letter S. Okay, for number 3, it says the universal set U is integers 1 through 10. So that'd just be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Set A is our even numbers 2, 4, 6, 8, 10. Set B is odd numbers 1 through 6. 1, 2, 3, 4, 5, 6. Set C is 5, 6, 7, 8, 9, 10. So it says give A union B. So A union B would be everything that's in set A along with everything in set B. So set A is 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Set B is 1, 2, 3, 4, 5, 6. So 1, I don't need to put the number 2 because I already have the number 2 here. I do need to put 3. I don't need to put the number 4 because I already have the number 4. 5, I don't need to put the number 6 because I already have the number 6. So that's A union B. Part B says give B not intersect C. So things that are not in B. So let's start doing that. So things that are not in B is everything not in B. So things that are not 1, 2, 3, 4, 5, 6. Well, so in this case, look back at your universal set, it'd just be 7, 8, 9, 10. So 7, 8, 9, 10. So that's not B. So now not B intersect with C. That means things that are both in this set, not B, and in set C. Well, if you'll notice, 7 is in both of those sets, 8 is in both of those sets, 9 and 10. So the intersection would be 7, 8, 9, 10. Because those 4 numbers are both in not B and C. And then part C says make a Venn diagram. So I'm going to do that on this paper. So A is the set 2, 4, 6, 8, 10. B is the set 1, 2, 3, 4, 5, 6. So if I say this is A, and this is B, 2 is in both set A and B. So 2 needs to be right here. It's not going to be down here because this is also set C, and 2 is not in set C. 4 is also in set B, and it's not in set C, so 4 is going to go here also. 6 is in set A, B, and C, so that needs to be right here in set A, B, and C. 8 is in set A, and it's also in set C, so it needs to be A and C, so 8 is going to be right here. And then 10 is in set A and C, 10, 10, so it's also going to be right here. Set B, the number 1 is only in set B. The number 2 is already in set B. Number 3 is only in set B. The number 4, we already got it right there. The number 5 is in B and C, so 5 needs to be right there. Okay, so now it's set C. 5 is already there, 6 is there, 7 is only in set C. 8 is over here, 9 is only in set C, and 10 is over here. So that's my Venn diagram here. Okay, hope that helps with the Venn diagram stuff. Okay, let's move on to number 5, counting from 1 to 10 in base 2. So for number 5, I'm going to make like boxes to put my answers in. So let's see. So this is how I'm going to write the number 1, the number 2, the number 3, because I'm counting to 10, 4, 5, 6, 7, 8, 9, 10. So I'm counting in base 2. So just a reminder, base 2, your digits, your possible digits for base 2 are just 0 and 1. Because once you get 2 of something, you bump it up to the next thing. So if I have 1 unit, that would just be 1 in base 2. If I have 2 units here, that's like having 2 small things. Well, I can combine those together to make a long. So in base 2, it'd be 1 long, 0 units. Base 3, if I had 3 units, I can put together 2 and turn it into a long, and I have 1 unit left over, so that would be 1 long, 1 unit. And this is in base 2. The number 4, so I can make this into a long, I can make this into a long. Let me do it like that. Well, then I have 2 longs. Well, 2 longs make a flat. Okay, so it would be 1 flat, 0 long, 0 units. The number 5, again, 1, 2, 3, 4, 5. These 4 units turn into a flat, and then I have 1 unit left over. So 1 flat, 0 longs, 1 unit. The number 6, if I was going to draw a picture of it, let me come down here. 1, 2, 3, 4, 5, 6. 4 of those turn into a flat, and then if I have 2 units left over, those are going to turn into a long. So 1 flat, 1 long, 0 units. The number 7, 7 units. 4 of them are going to be a flat, 2 of them are going to be a long, and then I have 1 unit left over. So 1, 1, 1. For 8, 4, 5, 6, 7, 8, these 4 are going to turn into a flat. These 4 are going to turn into a flat. Well, 2 flats in base 2 makes a cube. So that would be 1 cube, 0 flats, 0 longs, 0 units. The number 9 would be the number 8 plus 1 unit, right? 1, 2, 3, 4, 7, 8, 9. So 8 is a cube, and then I have a unit left over. So 1 cube, 0 flat, 0 longs, 1 unit. And then the number 10 would be 9, 10 would be 8, 1, 2, 3, 4, 5, 6, 7, 8. 8 units turn into a cube. And then 2 units left over turn into a long. So that's 1 cube, 0 flats, 1 long, 0 units. Okay, I hope you remember doing that. If you needed to, you could like do your powers of 2 here. Remember we did like 2 to the 0 power is 1, and that's the unit. 2 to the first power is 2, and that's going to be your long here. All right, so long unit. 2 to the second power is 4, and that's going to be your flat. 2 to the third power is 8, so that's going to be your cube. Right? So that might be helpful to write those out also for that problem. Okay, so the next thing I would like to go over is moving on to exam 2. We're going to go over 6, 7, 9, and 11. So starting with 6 and 7, the greatest common factor and the least common multiple. So for exam number 2 now, starting off with number 6. So finding the greatest common factor of 32 and 64. We have 3 ways we need to do it. The first way is listing all the factors. So listing all the factors of 32 would be 1 and 32. 2 times 16. Yeah. 3 doesn't go into 32. 4 times 8. And then 5 doesn't, 6 doesn't. So those are my factors of 32. 1, 2, 4, 8, 16, and 32. The factors of 64 are 1 and 64, 2 and 32, 4 and 16, and then 8 times 8. So there's all my factors. The way I find the greatest common factor is the biggest number they have in common. And in this case, 32 is the biggest number they have in common. So the greatest common factor of 32 and 64 is 32. So that's part A. Part B asks to do this using prime factorization. So this is where you break it down into the prime factors. So this is the factor tree thing. So 32 breaks down into, you pick 2 numbers, 8 times 4. 8 breaks down into 4 times 2. 2 is a prime number, but 4 can break down more into 2 times 2. And this 4 can break down into 2 times 2. So 32 is 2 multiplied together 5 times. Same thing with 64. 64 is 8 times 8. 8 breaks down into 4 times 2. 4 breaks down into 2 times 2. Same thing with this 8 over here. So 64 is 6 2's this time. So 1, 2, 3, 4, 5, 6. And once you have your prime factors listed out, the greatest common factor is all the factors they have in common multiplied together. So they have 5 2's in common. So the greatest common factor of 32 and 64 is 5 2's. And again, 5 2's multiplied together is 32. So same answer, just 2 different ways to do it. For part C, drawing a Venn diagram and shading where the greatest common factor is. So the Venn diagram for this, we use the prime factorization. So all these 2's right here. So this is the prime factorization of 32, the prime factorization of 64. So I need 5 2's in the 32 circle, and I need 6 2's in the 64 circle. Well, since they have 5 in common, I need to put 5 2's in the middle. 64 is going to have an extra 2. 32 doesn't have any more because 32 is just the 5 2's. So from there, you can see that the greatest common factor is the intersection of the 2. Okay, so this is the greatest common factor. And when you multiply those together, you get 32, which we know is the greatest common factor. Okay, let's do number 7. which is the same thing but the least common multiple. So least common multiple of 10 and 16. So for part A, we're listing all the multiples of 10. So the multiples of 10 are 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, so on and so forth. Keep on going. Multiples of 16, 16, 32, 48. Sorry, I'm doing this as I go. The next one would be 64. 64 plus 16 is 80. And that's the one they have in common. You could keep on going if you needed to. So the least common multiple is the one they have in common, which would be 80. So least common multiple of 10 and 16 is 80. For part B, same thing using the prime factorization. So first thing I need to do is break down 10 and 16. So 10 is just 5 times 2. 16 is 4 times 4, which each 4 breaks down into 2 times 2. So 16 is 4 2s. So the prime factorization, the least common multiple using the prime factorization, you do what they have in common, which they have the 2 in common. So it's 2 times whatever's left over now. 5, 2, 2, 2. So this is what they have in common, is the 2. Now this is the leftover stuff. 5 times 2 times 2 times 2. When I multiply that all together, I get 2 times 5 is 16, 2 times 2 times 2 is 8. I'm sorry, 2 times 5 is 10, 2 times 2 times 2 is 8, 8 times 10 is 80, which is the same answer as we got before. For part C, putting them in a Venn diagram and shading the least common multiple. So these are the prime factors of 10, these are the prime factors of 16. They have a 2 in common, so the 2 is going to go in the middle. 10 still needs a 5 over here. 16 still needs 3 2s over here. So 2, 2, 2. And the least common multiple is everything. Okay, so I hope that clears that up a little bit. Looking at number 9 on test 2, or exam 2. It says, if a brown Cuisenaire rod is 2/3 of the unit, what is 1/4 of the unit? So this brown Cuisenaire rod is 2/3 of the unit. So that means that right here, I was given 2 parts, and I know 3 make a whole. So if that's 2 parts, I need to find a Cuisenaire rod that splits that into 2, which I'm guessing it's the purple one. Let me see. Yeah, the purple one's 2/3. I'm sorry, the purple one represents 1/3. 1/3 plus 1/3 makes 2/3 here. So now, if I want to know the whole, I would put 3/3 right there, right? Because 1/3 plus 1/3 plus 1/3 equals 3/3, which is the whole. So this right here is 1 whole. Now that I have the whole there, it's not super difficult to find, what are we looking for? 1/4 of the unit. So here's my unit right here. Here's my whole, is this 3 purples. So let me find 1/4 of that. So let me guess if it's the green one. Do 4 of these make a whole? So yeah. So 4 of those make a whole. So that means that the light green equals 1/4. Because 1/4 plus 1/4 plus 1/4 plus 1/4 equals my whole here. Okay. The next one we want to look at is number 11. Number 11 is showing equivalent fractions using an area model, a line model, and a set model. So I want to show that 1/3, and 2/6 are equivalent fractions. So using the line model, I tried to help you out by telling you what to start with if we use a dark green as our whole. So if this is my whole, how can I show 1/3 and how can I show 2/6? So if this is my whole, 1/3 would be the rod that splits it into 3 parts. I'm guessing it's the red. Yeah. So the red splits it into 3 parts. That means that 1 red is 1/3. So this is 1/3. And then if I also want to show 2/6, you figure out which one gives you 6 making a whole, which would be the white ones. So you could measure it out and make sure that 6 of them equals the length here, which it does. So 2 out of 6 would be like that. So this is 2/6, and they have the same length, so they're equivalent fractions. So I showed 1/3 and 2/6 of a whole are the same length, so they're equivalent fractions. Okay, so that's how you would do the line model. To do the area model, I tried to help you out and told you use the yellow hexagon as your whole. So if this is my whole, the yellow hexagon, if I wanted to show 1/3, the blue parallelogram or blue rhombus splits it into thirds. So 1, 2, 3 of them. So shade in 1 of them. That's 1/3. Same thing for 2/6. The green triangle splits it into 6 parts and shade in 2 of them. So that's 1/6 and 1/6, which would be a total, you can't see that very well, which would be a total of 2/6. And this has the same amount of area shaded. Excuse me. So they are equivalent fractions. Okay, and the last one, the set model. I tried to help you out and gave you a set to start off with. So if I wanted to shade 1/3 of this set, I would shade 1 out of 3 parts. So shade in 1 out of 3 parts. So that is 1/3. To show 2/6 of this set, I'm going to draw the set again. And this time I'm going to split it into 6 parts, like this. And I'm going to shade in 2 of those sets. And so that's 2/6. And if you'll notice, the same number of dots are shaded. So they are equivalent sets. So I hope that helps a little bit showing equivalent fractions using the line, area, and set model. Next thing I wanted to go to was number 12 here. Okay, so given so for part A, we're given that this rectangle is 2/3. Okay, so I kind of went over this before the last exam, that you can only draw that rectangle. You can't add on to it, you can't make it smaller, you can't make it bigger. You have to draw this rectangle and draw multiple of them and shade it, or shade in less of it if you need less of that. So if this is 2/3, that told me I was given 2 parts, 3 make a whole. So in this case, he split this into 2 parts. This is 1/3, this is 1/3. So if I want to draw one, I have to draw that exact size rectangle, which is actually only 2/3, right? So that's 1/3 and 1/3. So I only have 2/3 drawn here. To draw another third, I have to draw the exact same rectangle again and shade in one of the pieces. Because 1/3 plus 1/3 plus 1/3 equals 3/3, which is a whole. So this was the answer I was looking for. For part B, if you're given that this is 1/3, the rectangle is 1/3, I need to draw one. So I need to draw 3 of those. So 1, 2, 3. And you can shade in all of them. So this is 1/3 plus 1/3 plus 1/3 equals 3/3, which is a whole. For part C, you were given that the rectangle is 1 1/3. So basically you were told that this is 4/3. Okay, so you were given 4 parts and 3 make a whole. So you split this into 4 parts. Each part represents 1/3. 1/3, 1/3, 1/3, 1/3. So if I want to draw a whole, I draw that exact same rectangle split into 4 parts. Each part's representative of a third, right? If I only want a whole, I'm only going to shade 3 of those parts. So this was the answer we're looking for there. And for part D, if I was given that this rectangle represents 3/4, I was given 3 parts. Let me redraw that. I didn't cut it right. I was given 3 parts. 4 make a whole. So this is 1/4. This is 1/4. This is 1/4. If I wanted to draw 1/2, a lot of you saw, well, I know 1/4 and 1/4 equals 1/2. And so you just went ahead from here and shaded in 2, and that was fine. Some people have to draw the whole first to be able to see a half. So to draw the whole first, you need to draw 2 rectangles, split them both into 3 parts. So this is the whole. 4 pieces make a whole. Half of that would be 2 pieces. So this is the correct answer. You could draw the whole if you needed to, or just go straight to the answer there. Okay, and the last thing I wanted to go over from exam number 2 is number 16. So drawing the fraction 5/2 using your 3 different models. Okay, so 5/2 using the discrete model, the area model, and the set model. So using the discrete model, you have to label a unit first of all. So let me say that 6 dots is my unit. So that's my whole right here. So if that's my whole and I needed to draw 5/2, 5/2 is the same thing as 2 1/2. So I would draw 2 holes. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that's 1 hole, that's 1 hole. Now I need to draw half. Well, split your hole into 2 pieces. So half of it would be 1, 2, 3. So that is 5/2. You could have 4 in each group, 5 in each group. It doesn't really matter what you start off with, just as long as you label your whole. You could have also drawn this as 5 pieces to make a whole, so you could have drawn it as 5 of the red circles like this. 3, 4, 5. That's the same thing. For your area model, excuse me, you could use the trapezoid if you wanted to, like the pattern blocks, or you use a rectangle. So if I said this rectangle equals my whole, 5/2 would be 2 1/2. So there's 1, there's 1. I need to split this in half and shade in what you want to use. So that would be an answer. Or if you use hexagons, there'd be 2 hexagons and a red trapezoid, so on and so forth. If I wanted to use the number line, I think most of you got this part right. My whole would be from 0 to 1, right? That's my unit or my whole. So then here's 2, Here's 3. Let me split that into halves. So half, 1 1/2, 2 1/2. That would be my 5 halves right here. 0 to 2 1/2. Okay, so I hope that clarifies some things from exam number 2. The things I wanted to go over on exam number 3 would be the word problems. So let's go through the word problems here. And again, on the word problems, it doesn't matter how you work it out unless it specifically says to draw a picture or to use this specific method. So let's look at number 11. It says Angie ate 1 slice of pie fresh out of the oven and Joe ate 1 slice. There were 5 slices remaining. What fraction of the pie was eaten? So if Angie ate 1 slice, so Angie ate 1 slice, Joe ate 1 slice, and there were 5 left over, that means the pie was cut into 7 slices to start off with, because these 2 plus what was left over. So there's 7 slices total. So the fraction of the pie that was eaten, this was the part that was eaten, so it would be 2 out of 7, because 2 were eaten out of 7 total slices. You could draw a picture for that or just kind of think it through. For number 12, it says draw a picture. There were 30 pieces of candy in the bags. If you're allowed to eat 2/5 of the candies, how many can you eat? So let's draw 30 pieces of candy. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 25, 26, 27, 28, 29, 30. So there's my 30 candies. If I can eat 2/5, that means I need to split this into 5 groups, and I can have 2 of those groups. So I can split it into 5 groups like this. 1, 2, 3, 4, 5. And I get to eat these 2. So, right here, these 2 groups, this is 2/5, right? That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 candies. So I can eat 12 candies because I can eat 2/5 of it. For number 13, it says at Keith's restaurant, 2/5 of the dishes on the menu are vegetarian. Of the vegetarian dishes, 1/2 are pasta. What fraction of the dishes are vegetarian and pasta? Okay, so I need something I can take a half a, actually, let's do it like this. So here's all the stuff that's on the menu. Okay, 2/5 of the dishes are vegetarian. So I need to split this into 5 parts. So of these 5 parts, 2/5, right? So 1/5 and 1/5. These are my vegetarian ones. I'm going to put a V there. And these are my non-vegetarian. Non-vegetarian, non-vegetarian. Okay, so this is 2/5 of it that's vegetarian. It says of the 2/5 of the vegetarian dishes, half of them are pasta. So half of this is pasta. So you could see it as one of these 2 pieces is pasta, or you could split all of this in half and say these are pasta. Either way will get you the same answer. Okay, so then it says what fraction of the dishes on the menu are vegetarian pasta. So both vegetarian and pasta. So vegetarian and pasta would be the things that are shaded both black for pasta and red for vegetarian, which would be 2 pieces out of how many make a whole? Well, this whole box is my whole, and there's 10 pieces, so 2/10, which reduces to 1/5. Okay. For number 14, it says that roommates, Bill, Dan, and Ed went to the grocery store to do some shopping. They figure based on how much of the time that they eat, that Bill has to pay 3/8 of the bill. Dan has to pay 1/3, and Ed has to pay the rest. And the rest was $35. So I need to figure out what fraction the rest of it is. So I'm going to take some kind of box and split it into something that's divisible by 8 and 3, which would be 24. So I'm going to take my box and do it. Let's see, let's do 3 this way and 8 this way. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3. So that's 24 pieces. So Bill needs to do 3/8. So 3/8 would be 8 pieces this way. Bill's gonna have 3 of those sections. Or out of 24 pieces, 3/8 would be 9 pieces. Dan is responsible for 1/3. So 1/3 of 24 would be 8. So 1, 2, 3, 4, 5, 6, 7, 8. So Ed's responsible for the last of it. So everything else is Ed's portion. Well, Ed has 1, 2, 3, 4, 5, 6, 7 little boxes here. So Ed equals 7 boxes. And we know that Ed's bill is $35. So that means each box represents $5. Right? So each box equals $5. So the bill would be the number of boxes times $5. So 24 boxes times $5, which is $120. Okay. Look at number 15. Or I want to go over number 15 on the review on exam number 3. So number 15 says write out the following in decimal form. 2 times 10 to the negative 2 plus 4 times 10 to the 3rd plus 5 times 10 to the negative 5th plus 3 times 10 to the negative 4th plus 6 times 10 to the negative 6th. So the way I like to do this is I like to make blanks for all these place values. So I have a 10 to the 3rd is my biggest one and 10 to the negative 6 is my smallest. So I'm going to start off and say this is 10 to the 3rd, and then it'd be 10 squared, and then 10 to the 1st, and then 10 to the 0 power, which is my units. So that's a decimal place there. Then we're going to go negative numbers, -1, -2, tenths, hundredths. This is my thousands, -3. 10 thousandths is -4. 100 thousandths is -5. And millions is -6. So now that I have them all laid out, it's not too difficult to put it in. 2 goes in 10 to the negative 2 spot. 4 goes in 10 to the 3rd spot. 5 goes in 10 to the negative 5th spot. 3 goes in 10 to the negative 4. And 6 goes in 10 to the negative 6. And if there's no numbers for the rest of them, they're all zeros. So your answer is 4,000. And this is, let's see, 20,356 millionths. 0.20356. And that's your answer. Okay, and the last thing I want to go over is number 26, the equality of 0.1, 0.10, and 0.100. And it says the cube is the unit. So let's show how these 3 things are equal using our base 10 blocks. So if the cube is the unit, that means that if I want to represent 1/10, that would just be 1 flat, right? So 1/10 is just 1 flat. Okay. This is 10 hundredths because I have the number 10 and the zeros in the hundredths place. So 10 hundredths would be, hundredths are represented using longs, so it'd be 10 longs. And then 100 thousandths would be 100 of the units, right? So units times 100. I don't want to draw out 100 units. You can just write 100 units written out. So how is this equal? Well, doesn't 1 flat equal 10 longs? And doesn't 10 long equal 100 units? Yeah, so these are all equal. because 1 flat equals 10 longs, which equals 100 units. So it's the same decimal because 0.1 is the same thing as 0.10 is the same thing as 0.100. You read them differently, 1/10, 10 hundredths, 100 thousandths, but they're all exactly the same because they're all representing the same number of units. So I hope this helps go over some of the harder problems to prepare for your exam. If you have any other questions that you need to go over, please let me know and I'd be happy to respond or make another video or whatever you need for your final exam. And just a reminder, your final exam, you've already emailed me the time, the location, everything. You can use all your manipulatives on your exam. Okay, so just a reminder, you can use your manipulatives on the exam, so make sure you bring them. This is on the final exam. So make sure to bring them. So you're bringing pattern blocks, Cuisenaire rods, base 10 blocks if you want them. You can use a matte pencil, colors on your final exam, and you get 2 hours for your final exam. Okay, so good luck, and when I get those graded, I'll post the grades online, and you can see your final grade. I've had a great semester with y'all, and I hope that you also had a good experience, and good luck in your next course.